Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the substrates. Compound A and compound B are enantiomers of trans-2-hydroxycyclopropyl methyl ketone, trans-1-acetyl 2-hydroxycyclopropane. They are a racemic pair, R and S, or the relevant trans enantiomers. Step 2. Reaction with NaOH, base, heat. The hydroxyl group is deprotonated by NaOH to give an alkoxide. The alpha carbon of the ketone, the cyclopropane carbon bearing the C is equal to O, is also activated. Under basic conditions, the alkoxide on C2 of the cyclopropane can initiate a retrocyclopropane ring opening or intramolecular aldol elimination sequence. Step 3. Mechanism. The key transformation is a base-mediated ring opening of the cyclopropane. The alkoxide acts as an internal nucleophile base. Deprotonation alpha to the ketone generates a carbanion enolate that is stabilized. With the strained cyclopropane and the beta-hydroxy ketone motif, treatment with base promotes a retroaldol or elimination. Specifically, the trans-2-hydroxycyclopropyl methyl ketone undergoes base-promoted ring opening. The C bond of the cyclopropane breaks, generating a homoallyl system. The ring opening of the cyclopropane beta-hydroxy ketone under basic conditions gives a 1,4-decarbonyl equivalent or an enone via elimination. The alkoxide leaves as the driving force from ring strain relief, and the enolate collapses. The net result is that the 3-membered ring opens to give a 3-carbon unit that, combined with intramolecular aldol condensation under heat, forms a 5-membered ring enone. Step 4. Product identification. Since both A and B are enantiomers, racemic mixture, they must give the same achiral product. The ring opening of the cyclopropane beta-hydroxy ketone and subsequent aldol condensation dehydration under heat yields cyclopent 2N1-1 to cyclopentane. This is a symmetrical, achiral product, consistent with both enantiomers giving a single compound C. The molecular formula, starting material C5H8O2, loss of water gives C5H6O, which matches cyclopentane. Step 5. Why other options fail? B. The cyclopropane diketone product would require oxidation and no ring opening, not consistent with base heat conditions on a beta-hydroxy ketone. C. Cyclohexane is 6-membered and would require AC6 framework. Starting material only has 5 carbons total, impossible. D. Option D appears to show a different cyclopentane isomer, double bond at a different position, but the conjugated cyclopent 2N1-1, option A, is the thermodynamically favored product under the heat condition. Both enantiomers A and B give the same achiral cyclopentane, confirming a single compound C is formed. Therefore, the correct answer is A. Therefore, the correct answer is option A.